All right, guys, I'm going to go through some of these word problem practice, kind of like application examples that I posted yesterday. Probably going to post either 2 or 3 videos just in case you have, a question on example number 3. You don't have to sit through a 45-minute long video waiting for that answer. So I'm going to post examples numbers 1 and 2 on this first video. So first example says you measure the depth at the end of the pier at high tide to be 28 feet deep. When low tide occurs, you measure the water to only be 16 feet deep. Assume the depth of the water can be modeled by the following function. So what it basically wants us to do is it wants us to be able to use our calculator to solve a lot of this. A lot of these answers are not like perfectly clean answers, so that's why it's really beneficial in order to use a calculator like a TI-84 calculator. So once again, if you have a TI-84, that's great. You can pretty much do the exact same steps I'm about to run through. If you don't, you can look online for online calculators. Desmos.com has some pretty good calculators and some functions that you could use. It's pretty user friendly. So if you don't have a calculator, it's not the end of the world. Okay, so first thing that I'm going to do is I'm just going to draw like a rough sketch of what this function is going to look like. It's not going to be accurate, but I just want to have some sort of idea of what I'm trying to solve for. So picture yourself like on the pier or something like that. My x-axis is going to be representing basically the ocean floor, and then this is my height. So the context in this problem, I know that this is going to be measured in feet. So my height is measured in feet. And then my x-axis is actually going to be measured in time. It's over a 24-hour period. So over that 24-hour period, just like my sine or cosine wave, it's going to start repeating the exact same stuff. So this is going to be time, and then I'm just going to do it in hours. Okay, so once again, this is just a very rough sketch. So just by looking at my function, I know it's a sine function. So remember, sine starts at the midline. My midline looks to be translated 22 units up, right? That's what that k value is, that plus 22. So I know I'm starting somewhere up here, right? I'm no longer at 0. I'm shifted up 22 units. And then it's going to just look something like this. All right, it's just going to keep repeating. I probably did one too many little periods there, but you get the gist there. Once again, this is just a sketch, right? It's starting at like 22 feet deep, and then it's going to go all the way up to 28 feet, and then comes all the way back down to 16 feet, and it just starts repeating that process, just like how the tide rolls in. Okay, so first couple things when we're using a calculator, I'm going to cover up my sketch here, is we want to first make sure the calculator's on. I'm going to delete whatever I have on there. You want to make sure your calculator is in radian mode. If you try to graph like a sine or a cosine function and you're in degree mode, it's not going to look pretty. So first thing you want to do is press mode, and we just want to make sure that we are in radian mode, which I am perfectly in radian mode, so I'm good. So I'm going to press second quit. Next thing I want to do is I'm going to go to y equals, which is my top left button here, and I'm going to type in the function that they gave me. So we have 6 sine of 0.503. It says t, but I'm going to use x. T just represents time in the problem. Our calculator uses x as the variable, so same thing. Close off the parenthesis and plus 22. All right, so this is like the most important thing over here. So if I were to just graph this in a standard window, so if I press zoom 6, it doesn't look very pretty. You actually can't even see it on my graph here. So I need to go through to my window, and according to the context, I want to make my window appropriate for it. All right, so I press window, which is directly to the right of y equals, and I want to go through and input some numbers here. So your normal window is like a -10 and a 10 in both the x and the y axis. This XSCL is the scale of your axes. So for example, if you're trying to get 7 days worth of information on your x-axis and you wanted to go up by 2s or you wanted to go up by 5s or something like that, that's what you would change the scale. Most of the time you just leave that as a 1. Okay, so we know the x-axis in my problem is representing time, and we care about that time over a 24-hour period. All right, so I always like to give myself a little bit of space to the left. So yes, obviously I'm starting at hour 0, but I always just make a little bit negative. So -2 is perfectly fine for me. My x maximum is 24 hours because after that 24 hours, it's just going to keep repeating the exact same shape. But once again, I like to get a little bit more than that so I can see where it actually ends on my calculator. If I went from 0 to 24, it would start at the very left and end at the very right, and you could sometimes not be able to see that entire picture. So I like to give myself a little bit of space on each end. Don't really care about the scale. I'm just going to go up by ones. That's perfectly fine. And then now my y-axis, as we already talked about, is feet, right? That's my height. And really, it doesn't go below 16 feet, right? That's my low tide. But personally speaking, I like to see the ocean floor. I like to physically see like the depth of the water. So I'm going to make this like a -2. You could have made this like a 10. You could have made it like a 15, just somewhere where you can see the 16. Doesn't really matter. And then my Y maximum, my highest the water gets is 28 feet deep. So just something a little bit larger than that so I can see my full picture. So guys, once again, this is kind of like subject to your own values there. You just want to make sure you can see the picture. So I'm just going to jot down what I wrote. My X minimum was -2. My maximum was a 26. My scaling was a 1. My Y minimum, I actually saw the ocean floor, so -2. My Y maximum was 30. I just had to get up to 28. My scale was 1. All right, so if I press graph now, I can actually see that trig function, right? My sketch was decent, not super pretty, but you can see I started at a depth of 22 because you shifted up 22. You got up to 28, and you went all the way back down to 16, and you just kept repeating that throughout the day. Okay, so graphed is good. Let's go through and read what the first question says. It says, use the graph to answer the question. After how many hours will the first low tide occur? So after how many hours will the first low time occur? Low tide is what? 16 feet deep. All right, so this is the 16 feet deep. All right, so once again, my calculator is going to do all of this work for me. All right, I'm going to go back to y equals, and I want to figure out that depth of the water needs to be 16 feet. So when is it first at 16 feet? So what I'm going to do is I'm actually going to have my calculator graph a horizontal line, that horizontal line being y equals 16. If I can graph that horizontal line of y equals 16 and I can find the intersection point here, it's going to tell me exactly how long after that it is going to finally be the first low tide. Okay, so come back down here under y2. I'm not going to erase my y1 value, and I'm going to put 16. When I press graph, I can now see my low tide marker, that horizontal line, and I want to find this intersection point, that first time it dipped below 16 feet, right? The first low tide. All right, so when I do this, if I'm finding that intersection point, I can press second trace. Trace is right to the left of graph. And I want to go down to intersect, which is option number 5. And then now it just asks me a couple of questions. It says first curve. You just want to make sure your cursor is on your Y1, which it is, so good. Press enter. Then it says second curve, question mark. You just want to make sure your cursor is on the horizontal line. It is, so press enter. And then now it says guess. So I'm going to take my cursor and I'm going to scroll over to where I think that first low tide occurs. It looks to be somewhere right there, so I'm going to press enter, and then the calculator does all of the work for me, hopefully. And it says my intersection is 9.37. We'll say 9.37. I'm just going to write that point down. 9.37 comma 16. So what this means is 9.37 hours after our starting hour, it was at its first low tide. So after how many hours? We're going to say approximately 9.37 hours, right? It doesn't tell us what to round to. I'm just going to round to the nearest 100th location. All right, next question. It says, high tide occurs twice a day. After how many hours will the second high tide occur? So we know that high tide is when my water is 28 feet deep. So relatively similar question here. Sorry, my handwriting's a little sloppy. Relatively same question here, but instead of my marker being at that low tide point, I'm gonna go back to y equals, change my y2 value to 28, and then when I press graph, my horizontal line should be at the top of my sine function, which it is, and I want the second time that it actually reaches high tide. So I see obviously the first time is right here. I'm just going to figure out how long, what is my x value at this intersection point. So once again, press second trace, because I'm trying to calculate that intersection point, go down to option number 5. you can always just press enter the first 2 times and then scroll over to where you think it's going to be. I'm going to put it right at the top here, right at that maximum. Press enter, and I get a value of 15.61 comma 28, which once again, that means approximately 15.61 hours into the day, the tide reaches its second high tide. All right, guys, so once again, just using your calculator. Hardest part here is figuring out what window works best, because once you guys have that image that you can see on your calculator nicely, you can just find the intersection points. So really, really not too crazy. All right, we're going to do example number 2, and then I'll post this video, and then I'll work on the following examples for you guys. So example number 2, it says, a Ferris wheel 98 feet in diameter makes 1 revolution every 160 seconds. The center of the wheel is 55 feet above the ground. The equation below can represent the Ferris wheel. So we're dealing with the cosine function in this example. It says, how long would it take to reach a height of 55 feet for the second time? Explain how you determine your answer. So this is going to be that second equation. I'm looking for the height after 55 feet. So I'm probably going to have to use y equals 55 as that kind of that horizontal line. Obviously, it's going to be a different picture than this. Okay, so let's just try to draw a sketch of what I'm looking at here so I can try to figure out what my window is going to look like. Please do not judge me on my artistic ability. So we have a Ferris wheel that is 98 feet in diameter. So the entire length across the Ferris wheel is 98 feet. All right, and the center of the Ferris wheel is 55 feet above the ground. So the distance from here, the center, to the ground, obviously the Ferris wheel has to be able to spin, so it can't just be, on the ground. It has to be off the ground. This distance is 55 feet. All right, so the entire height is from the ground all the way up through that entire top of the Ferris wheel there. Okay, so we're going to graph this. We're going to play around with the windows. Like I said, not every single time are you going to be perfectly correct on your window. I already know that my X is going to represent time in seconds. So my maximum is going to have to be at least 160 seconds. The Y is what I might have to play around with a little bit. Okay, so let's come over here, go back to our calculator, go to y equals, and I'm going to type in that given function. So it looks like it is negative 49 cosine of 0.039x, close the parenthesis, plus 55. And then I'm just going to kind of leave that blank for now. I know I have to use 55 here in a second, but I want to make sure my cosine function is good first. So let's go to our window. We know that, once again, I know that I'm dealing at the ground level, but I'm going to make this a -2 so I can see that ground. If you put a 0, you don't actually see the x-axis when you graph it. My maximum, I know I have to get to 160 seconds before my period starts repeating again. So I'm just going to make this like 170, 175, somewhere around there, just something more than 160. Sorry, I can't see this over here. My scale, I'm going to keep it as a 1 just for now. You might have to play around with that a little bit. Your y-axis, this is going to be your height. So I'm going to once again start at a -2. And just judging by my height here, I know that this 55 is going to have to add in another half of this 98. So if I just take 98 divided by 2 and then add 55 to it, I know that this entire height is 104, I think it's what, feet? Yeah, 104 feet. All right, the entire distance from the ground to the top of the Ferris wheel is 104 feet. So obviously when you're on the Ferris wheel, even if you're at the very, 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 very top of the Ferris wheel, you were only 104 feet off the ground. So I want my max to be something a little bit more than that. I'm just going to do 115 just to give myself plenty of space, and I'm going to keep my scale at 1 for now. Right, guys, this is not like set in stone. Like if I don't get this right the first time, I just have to go back and try some other numbers. Right, I'm just trying to get a ballpark idea of what my function is going to look like. All right, so I've already typed in my function. Let's go to our window and let's set these parameters. -2 is good, 170, remember that's my x-axis, so that's my time. I had to get to 160, scale is 1. Starting at a -2 just so I can see the ground, and you only get 104 feet in the air, so we're putting 115. If we press graph, do I get a good picture? Let's see. All right, looks decent. All right, let's go back here to our window. -2 looks pretty good. Okay, so now what I want to do is I want to figure out exactly what I'm looking for here, and that is when is my height going to be, how long would it take to reach a height of 55 feet for the second time? All right, so coming back here to our y equals, I'm looking for that when that height is the same for 55 feet for the second time. So let's go down here to y equals. It looks like, let me see this real quick. I have like an extra parenthesis in here. Let's see if that's affecting anything. Shouldn't really. All right, so 55 goes down here. Press graph. There we go. I was going to say it looked a little funky. Okay, so I can see my whole picture there. And then I'm looking for the second time that it reaches 55 feet, right? So obviously the first time is right here. My second time is right here. So once again, go to second trace. I'm going to go down to intersect. And then once again, press enter twice. I'm on my cosine function, so I'm good. I'm on my horizontal, my y equals 55 function, so I'm good. I'm gonna come over here to make my guess, and I get, let's see, 120.83. So that intersection point is 120.83 comma 55. So to answer my question, it says it's going to take me approximately 120.83 seconds to reach a height of 55 feet for the second time. To reach 55 feet for the second time. Okay, so once again, just being able to use that calculator. If you notice, I kind of struggled there a tiny bit just because I had like one extra parenthesis under y equals. I had one extra parenthesis after this cosine. So just, if you do see something weird, always just double check that y equals. Good little learning point there. But yes, we do get 120.83 feet, seconds, excuse me, to reach a height of 55 feet for the second time. All right, guys, that's the first two examples of the problems that I posted yesterday. I will be posting a second and third potential video today, helping us get through examples number 3, 4, and 5. So I hope you guys are enjoying your time home. Hopefully I get to see you guys sooner than later. All right, bye.